Welcome to this session where we will explore two of the most important concepts in the microprocessor and microcontroller. This is the RISC and CISC and von Neumann and Harvard architecture. These two topics from the foundation of how every processor and microcontroller in the world actually works. Whether it's your smartphone, your laptop, even your embedded system like a smart washing machine. Okay, all of them depend on this architecture of their speed, efficiency and performance. In this video we are going to memorize the definition. We will understand the real meaning behind every question and answers. We will see why RISC is a faster, why CISC is a more complex, and how Harvard architecture eliminate the bottleneck of the von Neumann design. So get ready to learn step by step, concept by concept, in the simplest and most logical way possible. Let's begin with our first question. What does RISC stand for? RISC, it means reduce instruction set computer. The term reduce means it has a smaller number of simple instructions. Each instruction is designed to execute very quickly, usually within a one clock cycle. It is a main function of the main concept of the RISC. Okay, the next question. What does CISC stand for? CISC stand for complex instruction set computer. Complex means it contains large number of instructions, many of which can perform multiple operations at a time. Okay, that is called the CISC. Okay, the third question. What is the main feature of the RISC architecture? Main feature, small set of the simple instruction. It is a main function features. Small set of simple instruction that execute in one clock cycle. Okay, main feature is small set of simple instruction that execute in one clock cycle. Okay, the focus of the RISC is the speed and efficiency. Okay, by keeping instructions short and simple, it can complete them faster and easily implement pipeline. So it is a simple instruction that execute in a one clock cycle. Okay, next question. Fourth one. What is the main feature of the CISC architecture? CISC architecture, complex instruction set computer. It is a use large set of complex instruction that can perform multiple operation. Okay, large set of complex instruction that can perform multiple operation. It was designed to make programming easier by allowing one instruction to do several tasks. Reduce the number of line in assembly code. Okay, CISC was designed to make programmer easy by allowing one instruction to do several tasks and reduce the number of lines in assembly code. Okay, this is the main feature of the CISC. Next question, fifth one. Which architecture has simpler hardware design? Which architecture has simpler hardware design? But obviously RISC, reduce instruction set computer, because it was fewer and simple instruction. That internal circuitry and control logic are easier to design and optimize. That's why RISC is a simpler hardware design architecture. Okay, next, sixth number question. Which architecture has more microcode control logic? Which architecture has more microcode control logic, that is a CISC, computer instruction set of complex instruction set computer. CISC processor use microcode to reduce and execute complex instruction. Okay, CISC processor use microcode to decode and execute complex instructions, which adds more layers of control inside the CPU. CISC processor use microcode to decode and execute complex instructions, which adds more layer of control unit inside the CPU. Next question: which architecture execute instruction faster? Which architecture execute instruction faster? That is a RISC. Since why RISC? RISC, in the RISC, each instruction is a small and execute in a one clock cycle. So it is a faster. Okay. Next question: which one takes fewer line of assembly code for complex task? Which one takes fewer line of assembly code for complex task? That is a CISC. Single CISC instruction can perform multiple operation. So it will take fewer line of assembly code to complex task. It can perform multiple operation. Okay. Next question: give an example of the RISC processor. ARM processor, MIPS processor, SPARC processor. These are the example of the RISC processor. These processors are built with the RISC philosophy. Few instruction, optimize performance and efficiency pipelining. Okay. Next question: give an example of the CISC processor. So CISC processor, Intel 8086 or x86 family. And these are the traditional desktop CPU that use a large and complex instruction set to handle the various operation. Okay. Next questions. Question number 11. Which architecture use pipelining efficiently? Which architecture use pipelining efficiently? That is a RISC. Because RISC instructions are uniform and simple. They can be easily divided with pipeline stages for the increasing the performance. So answer is a RISC. 12th question: which has variable length instruction? Which has variable length instruction? That is a CISC. CISC instruction differ in a length because each can be performed different operation and require different operands. That is answer for this CISC. Okay. Next question: which has fixed length instruction? Which has fixed length instruction? That is a RISC. All instruction in a RISC are the same size, which simplifies instruction decoding and improve the pipeline efficiency. So answer is a RISC. Next question: which architecture focus on a hardware optimization? Which architecture focus on hardware optimization? That is a CISC. Complexity of the CISC lies in a hardware which handle complicated instruction internally through the microcode. Okay. So answer is a CISC. Next question: which focuses on compiler optimization? Which focuses on compiler optimization? So that is the answer is a RISC. In a RISC, compiler's job is a break complex operation into the simple one. So software plays big role in efficiency. So next question is the 16th number. Which architecture generally consumes less power? Okay. Which architecture consumes less power? That answer is a RISC. So because of instructions are very shorter and simple, so less circuitry is active per instruction. That's why it saves the energy. So less power for the RISC. 17th question, which requires more memory for the code storage? Memory, more memory for the code storage. That is answer is a RISC, because complex tasks are divided into multiple small instructions. The total code size becomes a large. Okay, so RISC. Then next questions. 18th number, which one provide high performance per watt? High performance, that is a RISC. RISC achieve better energy efficiency, delivering high performance for low power consumption. So answer is a RISC. 19th, what type of addressing mode does RISC use? Few simple addressing mode. This reduce the decoding complexity and make instruction execution faster. Okay. The 20th one, what type of addressing mode does CISC use? Many complex addressing mode they are used. So CISC support multiple addressing format to make the programming more flexible. Through it increase the hardware complexity. Okay. Next question, which architecture used in a modern smartphone? Like our phone is which architecture use? That is a RISC architecture, like means ARM processor. Dex ARM processor are the RISC base. They provide the high performance with low power consumption. That's why our mobile use the RISC processor. 22 question number 22, which architecture dominate the desktop computer? That is the CISC, Intel and AMD x86. Desktop CPU prioritizes versatility and backward complexity, which CISC architecture handle the better. Okay. The next question is a 23 number question, which is a easier to design and implement? Which architecture? That is a RISC architecture. It is a simple instruction set, control logic make it easier, and it is a design and optimization is a very easier. Okay, so RISC is a answer. Okay, next, which uses more transistor to control the unit? Okay, that is answer is a CISC. CISC control unit has a decode and execute a wide range of complex instructions for their requirement more hardware. So answer is a CISC. Last question, which architecture can execute multiple operation in a single instruction? That is a CISC. The main advantage of this, one complex instruction can perform multiple tasks. Okay, so answer is a 6. Now let's move to the next topic, that is a von Neumann architecture and Harvard architecture. Okay, so question number 1. What is a von Neumann architecture? It uses single memory for both program instructions and data. It is a use single memory for the both things, program, instruction and data. So it is a von Neumann architecture. Okay, this design simplify the hardware, but main instructions and data share the same bus. Okay, that is a von Neumann architecture. Question number 2, what is a Harvard architecture? Harvard architecture, it uses separate memory for the program, separate memory for the data. So it allows the CPU to fetch both instructions and data at the same time. So it will increase the speed. That is a Harvard architecture. Question number 3. Who proposed the von Neumann architecture? So John von Neumann proposed the von Neumann architecture in 1945. He was the first to describe the store program concept where both data and instruction in a same memory. Okay. Question number 4. Which architecture use single bus for data and instruction? As usual, von Neumann architecture. In a von Neumann architecture, we use both data and programming in single memory. So we use the single bus. Okay. The question number 5. Which architecture uses separate bus for data and instruction? Harvard architecture. For the Harvard architecture, we are using separate memory for the data and separate memory for the instruction. Now, question number 6. Okay, which architectures allow simultaneously access the program and data memory? Harvard architecture, because Harvard architecture have separate memory for the data and separate memory for program, so we can allow simultaneously access the data and program. Okay, next question. Question number 7. Which architecture caused the von Neumann bottlenecks? Von Neumann architecture, because both data and instruction use same bus, so causing the delay. Okay, that's the bottleneck. Okay, it's create the delay. Okay, question number 8. What is the von Neumann bottleneck? It the perform the limitation caused by the single bus handling both the data and instruction. It the performance limitation caused by the single bus handling both data and instruction. The CPU must wait for the one transfer to finish before starting another one. So slow execution one in the von Neumann architecture. Question number 9. Which architecture is a faster in execution? It is a hardware architecture, because here we are using the separate memory for the data and instruction, so it can fetch the instructions and read write the data simultaneously, so it is a execution is very fast, so it is a faster execution. Question number 10. Which architecture is simpler and cheaper to design? That is a von Neumann architecture. Only one memory and one bus system needed, so it is a reduce the cost and design complexity. Okay, question number 11. Which architecture used in a most microcontroller like 8051 and PIC? That is a Harvard architecture, because we are using separate memory for the instruction and data. Microcontroller need speed and parallel access, so Harvard architecture suit the embedded control application. So we are using for the 8051 and PIC, we are using Harvard architecture. Okay, so next questions. 12 number question. Which architecture used in a traditional computer like the Intel x86? That is a von Neumann architecture. It is a general purpose computer, focus on the flexibility and large memory capacity. That's why we use here von Neumann architecture, or it is a support to the von Neumann architecture. Next question, 13th number. Which architecture allows self-modifying code easier? Which architecture allows self-modifying code easier? That is a von Neumann architecture. Data and instruction share memory, so program can be alter their own instructions if needed. So answer is a von Neumann architecture. So next 14th number question. Which architecture has separate clock signal for the instruction and data memory? Separate clock signal, that is a Harvard architecture. Each memory unit operates independently, so it is a requires separate timing control. Okay, so answer is a Harvard architecture. 15th number question. Which architecture is more power efficient? Answer is a hardware architecture, because parallelly data and instruction fetching reduce CPU idle time, so it's consuming energy. It's converging energy. It is a less using less energy. It is a more powerful. It conserving the more energy. Okay. Question number 16. Which architecture use a unified memory system? It is answer is a von Neumann architecture. Both code and data are stored in a same memory block, accessed through the single address space. So answer is the von Neumann architecture. Question number 17. In which architecture do instruction and data path interfere with each other? Answer is a one number, because single memory we are using. So single bus we are using. So answer is a one number architecture. Next question. In which architecture are instruction and data path independent? Harvard architecture, because we are separate, using the separate bus, separate memory and separate bus. So answer is a Harvard architecture. 19th number question. Which is a more flexible for the general purpose computing? Von Neumann architecture, because it unified memory allows more dynamically program, and it's suitable for the PC and laptop. Okay. Question number 20. This is the last question for this oral part number 2. Which is the more suitable for the embedded and DSP system? That is the hardware. This system need the real-time speed, efficiency, which Harvard architecture provide through the parallel access. Okay, this is the last question of the oral part 2. Okay, like the channel, subscribe the channel and share the video. Thank you so much.